Good morning, champs. I hope you're having ball at home, right? And please do not eat much. You'll get fat. Do not get fat as little as you can and as work as harder and as you can, right? So let's get started. And the prerequisite for today's class is that the serial communication with your Arduino, there is the serial communication is already configured and working between Arduino and ESP8266. Since your since your serial communication is already configured and is already working, what are we going to do right now? We are going to proceed ahead, and the agenda for the day is going to be this. We're going to toggle around, right, and using toggle two LEDs rather using Arduino and ESP8266. What does it mean? You are going to open your browser and send commands to ESP8266, and ESP is going to serially communicate using RX and PX pin 2 and 3. Right? So there are 2 and 3 pins. So you are going to take pin 2 and pin 3 and start serially communicating with Arduino, right? And that Arduino is going to turn on your LEDs and turn off your LEDs, or toggle between your LEDs. For that, we will create your ESP8266 as a web server and as an access point. And then what are we going to do? We are going to toggle between LEDs from the web browser, and those commands that we are going to send from the web browser, you can send it from your own mobile device. You can directly open and get connected to ESP8266, and you're going to send those commands from your browser, and those commands are going to control your LEDs today. So we are going to control, if I am able to control 2 pins wirelessly from mobile phone, so you can control all the pins. You can attach a relay board, right, and you can control the entire home wirelessly after today's class, inshallah. So I'll get started. Okay, so now this is my COM port and the serial communication is already working. Okay, let me get rid of these things. Okay, fine. Oh, no, I cannot get rid of this. Fine, so let's start. I have defined constant byte red LED on pin number 11, already attached. Green LED on pin number 12, already attached. If you can attach it to some other pin, 13 or 14, whatever, because I am doing digital communication, that's why I have attached my LEDs to my digital IO pins of Arduino board. Fine. So output, we know that I am going to turn on those LEDs. So those LEDs are only going to be output for me. And initially, I don't want them to be started. Initially, they're all low so that I can control them. If you're using a low triggered relay board, then what you got to do is turn it high initially. Because if it's a low trigger relay, right, if it's a high trigger relay, then there's no problem. You can keep them initially low. So now what do you want, and what is the process? I have defined a function send commands, and this command is going to take a command and timeout and boolean and debug. So what exactly is happening here? First, when we get when we start the Arduino microcontroller, I want to get connected to ESP8266, and I want ESP8266 wireless communication to be ready. So that's why we are using the modern style AT commands, right? But once I type AT plus RST, I hit enter and execute it. But here I want this to automatically happen. I want my ESP to take commands from my Arduino board, right? So I want my microcontroller to send commands to ESP, not that I will manually open my COM port and start communicating. No, that's not the case, right? So I want all the commands to be automatically sent to the ESP8266, so that we are connected to ESP8266, so that ESP8266 is working as a web server, is ready to accept multiple client requests, is ready to work as an access point. So that's why I've created this function. So let us call this function, right? So it's very simple. I'll call the function and I'll pass AT plus RST, and that's done. And timeout, maybe I want this to be executed within 2000 milliseconds, and debug is basically, okay, let me define this debug here. Hash define debug true. So I can keep this debug initially true, right? and I can pass this debug right here. So now, what is this debug for? Right? This debug is for to serially all right the communication between, or we can say to serially print all the communication. Debugging means you're checking what is happening. If I have passed 80 plus RST, you are opening your serial monitor and you check whether this communication is really happening or not, right? So this is how it works, right? And the third is debug. So we can, after you are successful in creating this module, after you deploy this module, you can turn it false. That means there is no debugging now, because you have tested all the stages. Now the software is working fine. But at development stage, the debug has to be true. So this is the actual style of modern style of programming. You cannot delete all the lines wherever you have written serial.print, right? You can set it to false and serial.print will not happen. Is that clear? Okay, sorry. Alright, so let's carry on with set commands. Now the first thing that I have to do using send command function is that I will create a variable string response back. And what this response back is going to do, right? So once I call send commands, right? So whenever I call send commands, right? So I'm going to return something back to the function. So let us declare this function as string, right? So it is about request and response. For example, if I go to Facebook, right, I type facebook.com, I send request to Facebook and the Facebook has sent response back. So the communication from the browser, always remember, is a two-way communication, right? So communication from the browser is a two-way communication where you send the request and you get a proper response. So request and response mechanism is what all web is all about, right? What your www is all about. Okay, I hope you have understood this thing, and that's why we created this response back. And also this response back is going to take whatever ESP is returning, and we'll print that to our serial monitor. And it's as simple as anything. I'll say esp dot print whatever command you have supplied. I've supplied 80 plus RST, which is reset initially, reset the module, which is ESP8266 module. This command will reset the module. Okay, and I'm going to print. That's as simple as anything. So communication, as I said, is two-way. Communication can never be one way. It's always two-way communication right here. So I am going to read. Now I have sent command to ESP. Let us see what ESP has sent us back. So I will say while, and the second thing is timeout, because you remember you set timeout to 2000. Now how are you going to make sure that the communication happens within 2000 milliseconds? If 80 plus RST has been printed right here, and if in case, let's say about your ESP8266 is busy and is not responding back, you have to time it out. If you don't time it out, you are going to hang your ESP8266 communication and the Arduino board, right? So that is why you have to set timeout. So timeout will be set like this. So I will say unsigned long, let's call this current time is equal to millis, right? So now you know that millis always keeps on running, right? It always keeps on running. And those who do not have any idea about millis function, I request them to watch two videos which are in the playlist, millis 1 and millis 2, so they'll understand what millis is doing. Millis will give us the current milliseconds since the time board has been turned on or Arduino has been turned on. So now when the millis is running, so you get the current time on the millis time scale and store it inside the unsigned long current time. So what I do now, I've sent my communication has happened, or I have sent the command back. So let me keep it here. So I sent ESP the command. Now what I'll do, I have to get back, but within a specific period of time. I have to get back. I will say while or until the current time, right? Until the current time plus the timeout is greater than, right, let us say millis, millis. You do this. So what does this mean? I'll keep it in brackets because I first want to add this and then compare it with millis function. Now let's say about current time. When I call millis function, it stores the current time, or we can say the time scale time in milliseconds in current time. Let's say about that is 2000. Okay, now 2000 and the timeout supplied here is 2000. Okay, we have passed the argument 2000 as a timeout here. So 2000 plus 2000 is equivalent to 4000, right? So I'll say 2000 plus 2000 is actually how much? So current time plus timeout is 4000. Okay, but what was millis? Millis was 2000. Okay, so now is 4000 greater than 2000? Tell me, is it? No, 4000 is never greater than 2000. Okay, it's always greater than 2000, but what I mean to say, while current time plus timeout, which is 4000, is greater than millis, yes, it's always greater than millis, but now I know that millis will keep on increasing. Millis increases and goes very big. So a loop is working like 2001, 2002, 3, 4, 5, 6, 7, 8 microseconds, right? So unless it reaches 4000, when it reaches 4001, you come out of the loop. So this is how initially it was 2000 and you supplied timeout of 2000. So that means within 2000 microseconds this loop has to execute, otherwise you'll come out of the loop. So this is how your timeout is going to work, right? So the current time plus timeout, right, and millis on the current timeline, which is always going big. The moment it goes more than this, which is whatever time you supply, in case at 2000, so the moment it goes more than 2000 plus the current timeline, you come out of the loop. That means you are giving this loop, whatever is inside this loop, a particular time or a timeline to get executed, or to execute the code whatever is inside this loop. I hope you have understood. I repeat, I'll give you another example. For example, if the current time is 1 and timeout supplied is 2, right? What is the current time? Current time mills, it is always 1. 1 plus 2 is 3, right? 1 plus 2 is 3. Is 3 greater than mills? Yes, but the mills keeps on growing, getting bigger and bigger and growing. So the moment it goes 4, this loop will not be executed. That means timeout is basically whatever we supply from here. So we'll supply different timeouts. Why are we doing this? Because we are going to supply different timeouts for different functions or different commands that we are going to send. Maybe I may send after this AT plus CW mode is equivalent to 2. So I am setting the mode to 2. CW mode is equivalent to 2 is going to turn on the access point mode. That means now my ESP8266 device will work as an access point. What do you mean by an access point? Access point is that you get connected to, right? So I'll now have to get connected to ESP8266. If I say 1, so 1 means it's not an access point, it's a station mode. Now my ESP8266 device will get connected to some other broadband router, or maybe you'll make your mobile as an hotspot and give credentials so that the ESP8266 device will get connected to other devices. Not that other devices will get connected to ESP8266. So if I turn the mode to 2, it means that other devices are now going to get connected with ESP8266 device. So is that clear? Okay, let's carry on. So unless the timeline keeps the timeout value, we are going to do this. Because now imagine what we have to do. We have sent command to ESP. Now we have to receive what ESP is sending us back. We have to receive the the response from ESP by 2 and 3 RX and TX pins. Okay, I'll say while ESP dot. So while ESP is available, right, I am going to do this. Char C, because we have to take ESP.read, it returns in char. So line by line read will happen in while loop. So I'll say while ESP is available. ESP dot available means when is happening. That means when both are available. When serial communication is happening, ESP is defined as using the software serial library. The communication is defined on pin number 2 and pin number 3. So when this communication is possible, and serial communication is happening over RX and TX pins, right? So then read line from the ESP, whatever your ESP module is sending back, and store it in char C. And now what I have already defined this response back. So I'll take it plus is equal to concatenate the output, right? And I'll say response back plus is equal to C. So now all the response will be stored in this response back variable. Okay, that's it. We don't have to do any more things. Yeah, I forgot. If I have to print, I'll say if debug. When debugging is true, I will print it back to my serial monitor. I will do serial.print and I will print the response back. Now if I turn debug to false, this print is not going to happen. So I suppose it's great. Good. So we are done with this part. Okay, now let's go back to send commands. So what commands do I have to send? Let me copy them. 1, 2, 3, 4 and 5 commands. I will document each and every command that we are about to send. Right, and yeah, I forgot one thing. Since the return type of the function is string, I have not returned anything back. So what I will do right here, I will return this response back. So I'm returning a response back which will take everything that ESP is going to give us back. I'm requesting ESP8266 and sending the command. ESP8266 sending me back something which I get by using ESP.read function, and what I do, I return back that, and I also print that. Print in case the debug is true. So returning back because the function return type was string. Okay, so now let me go and document the commands that we are going to use. So AT plus RST will, so I'll write it down to reset the ESP. You already know this, AT plus RST. And second, CW mode is equal to configure ESP module as an access point. And now what is point number 3? Right, point number 3 is get an IP address of the ESP module. You want to see the IP address of ESP module, and command 4 is going to be enable multiple clients mode, right, or multiple connection, and enable multiple connection mode on ESP. Okay, and now last but not the least, turn on the ESP web server, right? Turn on the ESP web server on port 80. As I said, ESP, we are going to make this ESP and configure this ESP module to work as web server. Why? Because we'll be sending commands from this. So for example, if I get an IP address 10.10.10.1 is the IP address of the ESP module, I will say pin is equal to 10. So now I'm targeting pin 10, but I require my web server to send a response back and to take this request, right? First we'll get the IP address of the machine, which is ESP8266, and then I will pass commands from my browser. Alright, so I've documented everything here. Yeah, one thing is very sure here that we have forgotten. Alright, so we require /r and /n. What is /r and /n? So I'll document it here. It is carriage return. Right, so what is carriage return? And it is carriage return, and /n is next line. /r is carriage return, and /n is, if I Google this, you can see /n and /r is going to be no, let's not Google it. We know that. Okay, if I hit 80 plus RST and then to execute it, I'll have to hit enter. So let's say 80 plus RST. Now when I hit enter, then and only then this is executed, right? If I don't hit enter right here, so it will not be executed. Now you can see it's 80 plus RST has been executed. If I say 80 plus GMR, and then still I have to hit enter to get it executed, right? So this /r means execute this command and go to next line, carriage return and next line. So once you have typed 80 plus RST, now you want to hit enter and execute it. To hit enter and execute it, you type /r and /n. So I'll type it everywhere, /r and /n /r and Alright, so we can see this right now. We are done. This time we should be able to test this. Why don't we test it first? Okay, let's test. Upload. Upload and test happily. Okay. Don't bother about anything. So once the uploading is done, open your serial monitor. 80 plus RST, okay. 80 plus everything is okay. 80 plus CWS, okay. Set the mode to 2, okay. Automatically, I'm not doing anything. You see, I am not doing anything, right? So everything is happening automatically, but one mistake. There's one mistake. We haven't changed the commands right here, right? Sorry. Okay. 80 plus CW mode is equivalent to 2. Turn ESP module as an access mode. Configure ESP module as an access point is done. Get an IP address of the ESP module requires command to get an IP address of the module CIFSR. So I'll say CIFSR. So 80 plus CIFSR will return the IP address of the device, and enabling multiple connections. So I will say CIP mux is equal to 1. If I say CIP mux is equal to 0, which is by default 0, means only one client can get connected to my access point. But if I say 1, I am enabling multiple connection mode. Now many clients can get connected to ESP8266. So multiple connection mode is enabled. And turn on web server. Okay, so I'll turn on the web server. I will say CIP-SERVER, and the CIP server is equal to 1. Turning on the web server, by default it's 0. Turn off the web server, and 1 means turn on the web server, and it takes 2 commands and port number 80. So if I say facebook.com or if I say gmail.com, do I type port number 80 here? No, I don't type port number 80. Why? Because by default your HTTP works on port number 80. You don't have to mention it, but yeah, you can start it on a different port, right? So if you want to start it on 1020 port, so that you can do. This is only for those who have port 80 reserved. Maybe your port 80 is reserved. Maybe you're using an IIS server. Maybe you are using a Tomcat server. Maybe at times the port 80 is reserved. Then you can change the port right here, right? So, but in my case, I'm going to use port 80. Let's upload and see whether we are getting connected to server or not. Alright, 80 plus RST, okay. 80 plus CW mode is set to 2, okay. 80 plus CIFSR, okay. 192.168.4.1 is my IP address, and 80 plus CIP server. Now the server has started on port number 18, right? So now let us target 192.168.4.1, right? So for that, I first have to get connected to my ESP module. I have kept it open I'll show you later on how to add username, how to change the SSID, and how to basically keep the username and password of the device. So that we can do also. But let me get connected to ESP device. Alright, so now I'm connected to ESP8266. I'm connected. So let me target the server and see what is happening from here. Alright. Okay. We should get no response back because we're not sending any response back. Alright, so 192.168, or let's say I am targeting pin number 11. Let's see, what do we get? Nothing. Okay. Let it execute because we are not doing anything, so we are not sending any response back, okay? But yeah, we have been able to successfully achieve what we did. Fine. So that's it. We were able to pass AT commands automatically using the setup. And why are we giving 2000 microseconds delay here? So it's too much, so we'll give 1000, 1000 and 1000, right? So everything will be now everything. If I close the serial communication or reopen the serial communication, 80 plus RST, okay, 80 plus CW mode, okay, 80 plus CIFSR, okay, you're getting the IP address, you can see 192.168, and you started server on port number 80. Absolutely fine, without any problem and without any doubt. So everything is working absolutely fine right here. Okay, let me upload it again and check it again whether everything is working fine. Because if anything that is not working fine, we can change the timeout. Okay, 80 plus RST, okay, 80 plus CFSR, okay, right, and you started CIP server on port number 80, okay. Every single thing that we were doing is absolutely okay. We do not have any problem at all. So let us go to loop now. We have to do the most complicated part now inside the loop, right? So what will I do? I will say if ESP dot available. Whenever ESP is available, whenever ESP is available means, right, RX and TX communication is on, right? So that is the first thing. Okay, the second thing is if I will say ESP dot find. Now what this ESP dot find function does, ESP dot find function will put cursor on anywhere near to what you say. For example, I say ESP dot find plus IP D comma. Now what is this ESP dot find IPD comma? So I will document it here. Means when ESP receives data from the client, right, so it means whenever ESP receives data from the client. So whenever IPD, I'll write it down here, okay, so reading, right, reading plus let's not see the whenever ESP receives data from the client. So when I send this data, I'm sending HTML 1.1, that means it's an HTTP request. Alright, so once I send HTTP request, it will be treated as an IPD request. I'll show you what this IPD is practically. Alright, but for example, my cursor is now at on. Where is the cursor? You can see this cursor blinking. Do you see? The cursor is right after O. Now the cursor is after O. Now when I say ESP.find IPD, right? So for example, IPD is here, right? So I say ESP.find IPD. Now instead of being at on, the cursor will go here after IPD. Right? Now the cursor is here. So what ESP.find does, right, will request for IPD. IPD means anything that you receive. The client request that you receive or your ESP device receives, right? So you want to turn on and take the cursor to IPD. Once you have taken the cursor to IPD, what you do is okay, let me see, Esp Dot Find IPD. What you do, I say int connection ID, whether 0 or 1. Connection ID can be 0 or 1. Esp.read. So I do Esp.read. Now, once I do Esp.read and drop anything, because either it has to be char. Now I'm using int because all the pins that I am using are, okay, they are pin number 10, pin number 2, all are integer pins. So what I do right here, I do Esp.read and I say serial.print connection ID. So let us see. I'm sorry. Alright, so let's see what we get now. Are we connected? Yeah, we're connected to ESP device. Okay, so let the server start first. We'll have to wait unless the server starts. Now the server is ready. Now let us send request from here and see. We are getting 48. Can you see this here? We are getting 48. Right here. I'll show again. When I request, we are getting 48 plus 1 now, 49. And now let us say again, we are getting 48. Right? So the connection is open. We are getting 48, 48, 48, 49. Okay. So we are getting it. That means we have started communication from the browser. Browser is communicating. You can see if I clear it out, okay, we are getting 50 now. Right? So you can see when I hit it, we are getting 49. Right? So that means there is the communication. The communication has started happening. But now what I will do right here is whenever I read ESP, I'll do minus 48. Why? I'll write it down here. Right? Why I do minus 48 is because ESP.read returns, right, and ASCII of 0, right, that is 48. So I'm removing the ASCII value that ESP.read function returns. It returns ASCII of 0, which is 48, right? So that's why I do minus 48, right? So now if I carry on and submit this, now we should, instead of 48, get 0 or 1. It returns the ASCII of 0, which is 48. So I'm just getting rid of that extra thing that it returns. Okay, the server is ready. Now see, what are we getting? 0. Can you see this here? Because I have subtracted 48 from here. What do you expect? 1. Okay, we are getting 1. Fine. So it has started working fine. So let us do another thing now. Okay, and debug is true. Everything else is working fine. IPD communication is also working fine. So after the IPD communication is successful, right, what you do here is Esp.find. Let's say I say Esp.find option, option is equivalent to, right? So I'll give you the brief about this. So let me tell you. So HTTP is all about request and response, right? Or let me make a file out of it. No, let me make a file out of it here. Now still I'll make it at the end, forget it. So HTTP is, or your www is all about request, and all those who are learning JSP and servlets will be able to, or any other web language will be able to understand it like a pro. HTTP is all about request and response, and we have two HTTP request verbs or methods, and those are HTTP get and HTTP post. Now please tell me what kind of communication is this. Okay, instead of pin I will say option. Option is equal to 11. Which kind of communication is this? This is get communication, right? I'll just basically now get submits request to the web server using HTTP header, and post submits the request to the web server, right, using a HTTP, or we can say HTTP body or HTML body, right? So get submit request to the web server using the HTTP header, and whereas post using the HTTP body. So I'll just keep it like this. So it's going to be this, 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 this. Okay, so post and get. So this is the difference between get and post. Let me show you an example of get right here. Right, so once you are using get, you're having two different options. For example, first option is the URL, which in our case is 192.168.4.1, and then it uses, right, the param, right, and then the value. In our case, param is option, right, and then the value is, you can see clearly here the difference. So this is the get, basically what get does. So I'll just document it for you. Now let us see. URL is this, crystal clear, and parameter is this, parameter name, option, and the value is 11. All right, so this is exactly what we are doing here. Now if you can see, we say 192.168.4.1, and pin, instead of pin we said option, option is equal to 11. So now what do you want, right? So I want to find option is equal to, because now before I run this find command, I already run find command, the cursor is near IPD. You're checking the IPD request, IPD data that you are receiving. What is the IPD data that you are receiving from the client, right? And here what you are doing, now you are moving cursor from IPD to option right here, right? So only when I move my cursor here, after is equal to, will I be able to take inputs from the URL. So option, the cursor is here, I've taken cursor here, now you can see the cursor is blinking. Then I can say give me the option that's after the cursor. I hope you got it. Okay, right? So after that, let me execute it and see whether he's able to find the option. Yeah, so let the service get started. After the server is successfully started, okay, the server started on port number 80. Option is equal to 11. So let's see the cursor. 0, right? So no problem at all, right? Now we should get 1, no problem at all. So everything is working absolutely fine, right? So send command is working absolutely fine, right? ESP communication is working absolutely fine, right? So we do not have any problems whatsoever here, right? So yeah, so let's carry on and do the rest of the job. Okay, so now after you say Esp Dot Find, option is equivalent to, you're taking the cursor, I'll write it down, move cursor to option is equivalent to, which in our case it is the get parameter that you are supplying from the URL, right? Okay. So now we are done. I suppose now we have to take the input and light on the LEDs. I don't think there is anything else that we can do. Let's say int pin number take the pin number is equivalent to, let us say, ESP dot read minus 48, right? I know that, let's see what this pin number does. Okay, let's see. Minus 48 because it returns an ASCII of 0. I want to get rid of it. Upload, check back, and it starts working. So let's get connected to ESP. 80 plus RST okay, 80 plus CW mode okay, 80 plus CFSR okay, 80 plus CIPS server okay, everything is okay. So option is equal to 11, so we are getting only 1, right? So that means once we are doing esp.read, it, when I say minus 48, it returns the first digit of the first number. So get, I'll write it down here, get the first number. You know, if I say 11, right, the first number is 1 and the second number is 1, right? So get the first number, and to make it, let's multiply it with 10 so that we get, instead of 1 we get 10. So get the first number here, right, and multiply it with 10, right? So if I say I supply 1, I do into 10 is equal to 10, right? And let me show you why I do this. I will say now pin number already has 1, so I'll say plus is equal to add to my pin number the second pin number, right? So now let's see what the pin number is. First, you are taking the get the first pin number and multiply it with 10. Here you are not multiplying. Get the second number. Now let me show you. Go and take your cursor to option is equal to. Now the cursor is here, right? So I'll show you this. Take the cursor to option is equal to. Where is the cursor? It is here. First time the loop runs, what are you going to get? ESP.read minus 48. Remove the ASCII value. What are you going to get? First value. Please tell me. What is the first value? 1. You can see here. 1 is the first value. I'll highlight it. 1 is that you are getting, but you have to get the second one as well, right? So I'll say multiply it with 10. That means it is now, instead of 1, it is 10. And now you are reading the second number. What is second number? 1, right? How much is 10 plus 1? 11. If I say 12, how much is 10 plus 2? 12. How much is 10 plus 3? 13. So it's going to work like this. Now if I do a serial.print of pin number that we are supplying, if we do this, our job is done, set and done. Go ahead and do your job. Okay, so let's see. The server is ready. Okay. Option is equal to 11. 11 we are getting here, right? We can clearly see we are getting 11 right here. What is option? Option is 12. You can clearly see we are getting 12 here. Let me clear. Let's say I supply pin number 13, so we are getting 13 here, right? And let's say I supply pin number 14, we are getting 14 here. Basically we are not getting an IPD response. That's only because of the fact we are not giving delay. The moment you find IPD, let me have a delay of 1000 milliseconds. So after having a delay of 1000 milliseconds, okay, let me see what is going on. Okay, let me do another thing first. So let me close the connection as well. Okay, so I'll say string, because in order to open a new connection you have to close the previous connection. So I will say close. So I'll say string close command is equivalent to, what is the close command here? 80 plus close, and you have to supply the connection, whether it's 0 connection or 1 connection. So I'll say 80 plus close is equal to, then I will concatenate the connection ID here, close command plus the connection ID. So after supplying the connection ID, execute. So I will say close command plus is equivalent to add the carriage return, and the next line means execute and go to the next line. And then right, so I'll call the function send commands, which is already ready for me. So I'll say send commands and I will supply close command. So this is going to show us the input and output IPD response, and 1000 milliseconds, and debug debug. So I supply the third parameter debug here, which is true. Upload and see. Now you'll be able to see everything. Input, output, whatever you want is going to be available here. Now the server has started. Now see, the moment I send the request on pin number 14, right, you can see that I get an IPD response, HTTP 1.1. The host is 192.168.0.4.1. So this is the IPD response we were looking for. If I say 11, now you can see I get 11, right? So this is an IPD request, not the response, sorry, IPD request that is coming from the browser, right? So let me see, 80 plus close is not the command, it is 80 plus CIP close. Okay, so let me run 80 plus CIP close. Okay, let me see now. Alright, server is ready. Let me carry on and type pin number 11. Yeah, cat, what is cat plus close? Have I written cat? No, it's 80 plus close. Okay, IPD is basically responding 80 plus CIP close is equivalent to, I suppose it should work fine. So let me just get rid of this slash. Option is equivalent to 11. So let me see. Okay, so instead of getting 80 plus close, I'm getting cat plus close. So maybe we're doing something wrong. What is the last command? Carriage return. 80 plus CIP server is working absolutely fine. 80 plus CIP close, and then we have slash n and slash r. Okay, I have forward slash here, so there's a mistake. It is not forward slash but backslash. Let me upload it again. You can see, right? So here slash n slash r, slash n slash r. Alright, so let me see this again. Done uploading. Let us prepare the server. Okay, 80 plus RST is having error. Just a moment. It's because I have not closed the previous connection, no problem. Okay, 80 plus RST, okay, everything is okay. Yeah, everything is okay. Server is ready to take request, so let me give the request. Option is equivalent to 11. Okay. Option is equivalent to 11. 80 plus CIP close is going to throw error, so I will disconnect and connect back, because there are many open connections. We did not close that, right? So now our 80 plus CIP close is going to work fine. Slash r and slash n. Okay, fine. Let us see. Fine. Okay, server is ready. Now send the command 11. You are getting it from HTTP 1.1, but 80 plus CIP close has an error. Let me fix it and come back for you. Alright, I found the error. You know what we are doing here? String close command is equal to 80 plus CIP close is equivalent to. But what we are doing, we're replacing, we're adding, we say close command is equivalent to connection plus connection ID. So it does something very ridiculous. So what we have to do, we have to concatenate 80 close command plus is equivalent to the connection ID, which is either 0 or 1. So close command execution. Okay, so let's see this now. The only error I found was we were not concatenating but adding these two values. Okay, let's see now. Done uploading. Because if you don't close the previous connection, you'll not be able to create another connection. Okay, now the server is ready in our case. Okay, and let me see now. 80 plus 192.168.4.1 option is equal to 11. So what do we get? 11. And the connection has been successfully closed. And you can see the IPD response. Can you see this? Now, first you have to take the cursor here. Okay, I'll show you this IPD. Now, what you have to do, once I say find IPD, and I have even typed comma, so now the cursor reaches here. Once the cursor reaches here, after IPD plus comma, then you get the first character, right? So that's where you have to see whether the IPD response is coming or not. Once you say find, that means you're getting input from the client. If you're not getting it, there's no fun in executing these things when there is no request from the client. Okay, and then after that the cursor is here, you say find, go to option now. All right, so you take your cursor to option, which is here, right here, and get the first character -48, second character -48, and similarly we're able to get all the pins. Now we are set and done. So let me execute. Get rid of serial.print, do digital write the pin number, and if you have to toggle it, so I will say digital read the pin number. So this is how you can toggle it. When you digital read the pin number, it is going to give you on. If it is on, turn it off. If it is off, turn it on. So you are doing not. Not means digital write to pin number either high or low. Now if the pin is high, you say not, you are setting digital writing it to low. If the pin is low, you are doing not, you are setting it to high. So what you are doing here is toggling. Toggle around LED or toggle LED pins. Toggle means on and off. If it's on, turn it off. If it is off, turn it on. Upload it and test it from your mobile device now. Alright, so uploading is done. Now I'm very eager to turn on my LED and control all the Arduino pins from my browser. The browser can be anything now. Let me get connected to ESP first. So am I connected to ESP? I should be. Yeah, I'm connected to ESP. And let us see the connection status. Let me see the connection status. Serial monitor is open. Fine. Okay, the server is ready. I go and hit pin number 11. Yes, LED lights up, so I'll say pin number 12. LED lights up at pin number 12. Turn off LED. LED is off. Turn off LED. LED is off. Okay, fine. Now you can see that it is all about request and response, but here I am not getting any error here, but it says did not send any data, empty response. That means the request was successfully executed, but the request did web server, the server that you have requested for, or the server is not sending any response back. So let us send the response back here. We have to send the response back. Okay. Before I close the command, I have to send the response back. Okay, let us say, okay, let's say string response. Let us say string response is equivalent to 80 plus CIP send. So this is how we send the response back to the browser. 80 plus CIP send is equivalent to, what do you want to send now, right? So I will say response plus is equivalent to, again I'll use the same connection ID that you want to send the response to, right? And I will send let us say response plus is equivalent to concatenate. I will concatenate comma CIP send, and let us send CIP okay, so let's say response plus is equivalent to let us say digital read on pin number. So I'm going to send this response back. So I will say digital read pin number, right? If it is digital read pin number, I will say right, if digital read pin number is 0, turn it on, okay, else turn it off, right? So it is if and else. So now the response I will say plus is equivalent to executed, carriage return, and the next line. And now before you send the close command, you also send the response. First send the response back to the browser and then close command. So let me execute it. Done uploading. Server has started. Yeah, server is started. Now if I pass 11, let us see the response I'm getting back. I'll have to wait for the response. Yes, connection closed. Aren't we getting any response? What did we say? Connection. So I have to send 80 plus CIP send. So what did I write? 80 plus CIP send. I'm sending the response. Okay. Alright, so wait a second. I will not send this right here, so I'll just delete it. Alright, so let us create a web page here. So I will say, let me create a web page here. So I'll say string web page, that the response is going to be string, right? Send and convert it to string, digital read the pin number, because I have to read the current state of the pin number. If the pin number, right, is 1, so this means if the pin number is 1, right, or true, if the pin number is true means it's 1, then send on, right, else send off, right? So this is how we will get the current state of the LED. So now we have this web page, CIP send, and you can send right here. After the comma, I will say response plus is equivalent to web page dot the length of the web page, how much long the web page is, right? So I'm going to use the web page dot length. So this is the length, so I'm sending it as a response, and I do string send commands here. Alright, so let me make you understand what is happening here. I've created a web page. Web page is nothing. Show me on or show me off. That's it, right? Okay. The second thing that I'm doing here is I'm preparing my web page response, which is sent using 80 plus CIP send, right? So I'm doing 80 plus CIP send, and I'm sending I'm concatenating response with the connection ID, comma, length of the web page, and execute it. After I've executed it, right, what I need to do, I need to basically send the web page right here. So I'll send this web page now and then close the connection. It's not the connection that you're closing, it's not server you're closing the current client communication between ESP and you. Now the web page is also sent and the connection is closed. Okay, this is the final try that we're making here. Fine, make sure ESP is connected. Yeah, ESP is connected. Okay, the server has started. So let me say pin number 11. Okay. Is there anything wrong? No. Absolutely fine. So am I able to turn on the LED? Yeah. Turn on LED. So wait for the response. On. Yes, we have got the response back now. Now the current state of my LED is on. Now if I set it back, right, so let us see the current state of my LED is now off. Now let us say what is my current state of 12 LED. It was off, now we are going to turn it on. Alright, so no response, so let me wait again. Yeah, so the response will come as on now, right? You can see you're getting on. Now if I set it again, right, so I have to get off now, right? So because we are turning it on. Okay, pin number 12 is on. Now go ahead and execute it again. It should turn pin number 12 off. Yeah, absolutely fine. Now I will do one thing. I'll just connect my mobile device and type 192.168.4.1 in the browser, and I will come back and show you the demonstration live. Bye-bye. Alright champs, as you can see, I have connected two LEDs right here, and I have connected to my mobile device with ESP8266 wirelessly. And now I am going to open my Google Chrome browser, and I'm going to type 192.168.4.1 option is equal to 11. Right, so as soon as I give option 11, the red LED, as you can see, lights up. If I give option 11 again, so you can see that the red LED will turn off as soon as I give option 11 back. So it turns off. Now what I will do, I will type option is equal to 12. So let's see what happens on option 12. Yeah, just a moment. I typed 11 again, so I'll have to type 12 and 11. It turns off. Now if I give option number 12, so it should light up my green LED, right? Just a moment, it is on. Perhaps something is wrong with the LEDs. Perhaps it's absolutely working fine. Green LED lights up. You can see option number 12. Now if I type option number 12 back, green LED gets off. And if I type option number 11, red LED should turn on. Okay, let me try option number 11. Red LED turns off. Now let me try both. Right, so I will try both of them. Okay, so wait a second. So option 12, both are working fine. So let me turn off both. Right, so 11 is off, 12 is off, and let me turn on 11 as well. So both LEDs off. So it's absolutely working fine. If I can control these things, I can control anything. Let me turn off this right here, so that I can give you some more brief description about what is happening. All right. Okay, so now you have seen that we successfully serially communicated, and we have made a web server. We have made ESP8266 as access point, ESP8266 as a web server, right? So now that's not our goal. We are not going to send commands via address bar. What our goal is, we will make a nice website with the full controls, right? With all the controls of our home or entire building, analog inputs, controlling fan, controlling washing machines, and using sensors to turn off devices, using motors or maybe servos to automatically sense. A complete home automation system we are going to develop in the next class, and we're not going to use these parameters. We are going to develop a complete solution, design a very nice website, wherefrom we can control each and everything of our home. It can be a project, it can be anything, or it can be a complete entire building project that we have to engineer now without using any third-party application. So today we have seen the request and response, and before we move to next class, what I request you guys to complete it and understand it thoroughly, right? And you can ask questions. I am available for you guys, right? And I'm going to make a file of it, and plus I'm going to ask you 2 questions. Now what you need to do is to encourage your instructors that you're not before us, you're not in front of us, so that we can stop you, and when your attention is not there, right, we cannot make you attentive in the class because you're not in front of us. So in that case, what you have to do is encourage your teachers, right? When we ask you to answer a certain thing, considering that the teacher is not watching me and he's not in front of me, and I'm loyal enough to tell him that, hey, you're working very hard in making these videos for us, right? And as a sort of encouragement, you have to do these things, right? Whatever we ask you to do, so that we also feel that we are not wasting time. We are making videos for someone who has passion and is working 24/7 and is working very hard. And the more harder you work, the more better content we make. And please answer the following questions. And I don't have to beg for it, right? So please answer them as soon as you understand and complete it. Number 1, what is the, or define what Millis does. Question number 1. Please note question number 1. Define what Millis does. And you have to answer in the comment section. Please do not post your answers in WhatsApp group, or do not message me your answers. Comment section, right? And the second question is basically why are we using not digital right pin number here, right? So why are we using this? So this is the question right here. I'll post it. Why are we using it here? So I'll write question number 2. Right, because we are doing digital write pin number and digital read. So digital write depends on digital read right here, and I will write it down here. This is question number 1. Question number 2, right? And question number 3 is going to be right this. Okay, I'll write it down here only. Question number 3, why is it required to minus 48, right, after ESP dot read, or after calling ESP dot read? So why are we doing minus 48? So there are only 3 questions. Number 1, define Millis, what Millis does. Why are we using not digital read when we use digital write here, right? And question number 3 is, why is it required to do minus 48 after calling esp.read function? So each and everything is before you, right? And second thing, whenever you try from your mobile phone, if you're trying to get connected from your mobile phone, you connect Esp module from your mobile phone, right? And you pass those parameters. Make sure your data connection is off. If your data connection is not off, you're not communicating with ESP, you're perhaps communicating as that of internet, right? Which is not going to give you any response. So in order to make it work, please make sure that your internet connection is off. And I'm going to show you much advanced things. I'm going to show you the sleep mode, the complete sleep mode, full sleep mode, half sleep mode, right, and power saving mode, every single thing coming in the next lectures. And the prerequisite for the next lecture is that you have understood this lecture completely and you're controlling all the pins from your mobile device nicely. And the next lecture is going to be designing a very good platform, and it's going to be a real fun, right? So enjoy and let me know. Bye bye, take care.